welcome to Ramta Solutions and welcome to your grade 10 quantitative aspects of chemical change. So in this video, we are looking at elemental composition. Okay, so guys, what we know about composition generally is that basically, let's refer to perhaps chemical formulas. We know that chemical formulas are the best way of representing elemental makeup, right? So if we know elemental makeup of a compound, we will know the chemical identity of this compound. For example, we know that our water is made of 2 hydrogen atoms and 1 oxygen atom, right? We know that that is the composition of water. This, we can find how much hydrogen contributes to the overall molecule of water, and we can also find how much oxygen contributes to the overall compound of water, right? So now, with what we are going to do in this video is that, one, if we can measure the mass of each of the elements making up a compound, we will then be able to determine the formula experimentally. Okay, but this, we will get to see it later in a video that focuses on empirical formula. Okay, one that focuses on empirical formula and molecular formula. Okay, so now with elemental composition, basically this gives you how much an element contributes to that compound. Okay, so what we are expecting here is that we will be given, we will be given a molecular formula. Okay, let's say we're given a molecular formula. Okay, let's say we're given a molecular formula. What you will need to do, you will need to find the percentage that each element contributes. Okay. That each element contributes. Okay. Okay. So what we are going to do, we are going to use this formula, the one that we had in our opening slide. We are going to use this formula that says percentage of an element is equal to atomic mass. Okay, is equal to the atomic mass of that element over the molecular mass of that compound. Okay, over the molecular mass of that compound. Okay, over the molecular mass of that compound. Okay, so this is how you are going to calculate your percentage or percentage composition. Okay, this is how you are going to calculate your percentage composition. Okay, so alternatively, you can say this. You can say this is percentage element if you like. Okay, you can say percentage element is, I'm going to say this, number of atoms. Okay, number of atoms multiplied by relative atomic mass. Okay, relative atomic mass of your element, relative atomic mass of your element over molecular mass. Okay, over molecular mass. Okay, times 100, of course. You can use this one as well. Okay, you can use this one as well. So either of them work, they do the same thing. I prefer the bottom, by the way. I prefer the bottom. Okay, so without any waste of time, let's try some examples. I think we will try about two examples. Should we try 2? Yeah, let's try 2. But even 1 is okay. So let's say now example 1, calculate percentage composition. Okay, calculate percentage composition of each element in H2SO4. This we call sulfuric acid. Okay, so what we are going to do now is this. We are going to say, let's say, relative atomic mass of all these guys. Let's get our solution. Perhaps let me change the color. For our solution, relative atomic mass, we're going to call it master. So master H is 1,01 gram per mole. Master sulfur, we're going to call him, or rather he is 32.1 gram per mole. And then oxygen will be 16,016 gram per mole. Now from this, let's now try to find master sulfuric acid. Okay, let's now try to find master sulfuric acid. So what is master sulfuric acid? What is it? It is 2 times 1,01 plus 32.1 plus 16.0. Let's quickly get our answer. What is it? It is 2,02 plus 32. Oh, I'm supposed to say 4 times 16.0. My mistake. Okay. What is our answer? We are getting 98.12. 98.12 gram per mole. So guys, remember, you will find these relative atomic masses in your periodic table. Okay, you will find them in your periodic table. Use the ones in your periodic table that will be supplied to you during your exams. Okay, perfect. So master sulfuric acid is 98.12 grams per mole. Okay, now let's find the percentage composition. Let's find the percentage composition of hydrogen. If you recall that formula, let's go check it out. You can use this one, or you can also use this one. Perhaps let's take this one. So we will say it's important that you write your formula. So percentage element, okay, percentage element is atomic mass over molecular mass. All right, atomic mass over molecular mass. Okay, multiplied by 100. Now let's look at percentage hydrogen. Hydrogen, how many hydrogen atoms do we have in this molecule? 2. So it'll be 2 times, what is the atomic mass? It is 1,01. So it's 1,01. What is the molecular mass of sulfuric acid? We said it's 98.12 multiplied by 100. You will get our answer later. Then we proceed to sulfur. We have 1 sulfur in this molecule. And this will be 32,1 over 98.12 multiplied by 100. We will get our answer later. Then we look at oxygen. We had 4 oxygen atoms. So 4 times 16.0 over 98.0 or 98.12, all multiplied by 100. Okay, so let's see. We have 2,02 over 98.12 multiplied by 100, of course. What do we get? We get 2, I'm not rounding off as yet, 2,05870 and so on %, isn't it? And then let's get to sulfur. We have 32.1 over 98.12. What do we get? We get 32.7150428%. It's fine. And then let's go to oxygen. What do we get? 4 times 16. 4 times 16 will be roughly 64, yeah? So it'll be 65.22625.357%. As you can see, this is roughly 2.06%, and this is roughly 32.72%, and then we get to this guy here, 65.23%, right? 65.23%, right? So when you sum all these, they will be equivalent to 100%, all right? They will be equivalent to 100%. Let's try this. I'm going to take this number as it is, 65.22625357 plus 32.7150428 plus 2.05870. When I look at it, it is 99.9999. This is roughly 100, right? So this is the percentage composition of each element in sulfuric acid. Can you guys see that? This is the percentage composition of each element in sulfuric acid. So this is how you do your calculations of percentage composition. Okay, I thought we can do a second example. No, let's leave it here. We will only use this one. You do this for each and every question that might come your way. Okay, guys. With that being said, I was Ant here. And remember, if you would like to get in touch with us, you can visit our website, www.ramtasolutions.co.za, or you can follow us on your favorite social media platform, being it Facebook, X or Twitter, and Instagram. So because you are watching this video on YouTube, please subscribe, like, and share with your classmates and friends and everyone who might need this information. And of course, you can also contact us on WhatsApp. If you would like to get a tutor, you can email us. You will see direct links on our website. You will see direct links to either our website and WhatsApp. If you go to our website, you will find, when you click on these icons, you will get a link that directs you to our WhatsApp or emails. Okay, with that being said, I was Ant here, and bye-bye.